Hello world and what's up? My name is Brendan. Welcome to the channel. Today guys, we're going to be talking about the ant simulator here. Hopefully my audio is a little bit better so you guys can hear me. But yeah, basically we're going to be doing not a huge intro here, but we're going to be covering the setup and the ant class, and we'll see wherever that takes us from there. So yeah, let's get right into it. Alright, so basically last time we talked about what was going on up here, and then a bunch of global variables. If you're interested in that, check out the first video there. All right, so I've already said the screen width here. The reason why I don't just enter 1920 or change this into screen width is because setup is called before these variables are actually initialized, so I can't actually just set that to screen width. Right? You guys get that? Okay. Boom. Our draw method. Our draw method is the next method to be called after our setup. Basically, I'm just going to be setting the background color here to one of those global variables that we talked about, which is the background color. And then on this world that we had initialized up here, I'm going to go ahead and call update on that. So it's going to do all the different updates, whether it's calling out to the ants. I think it's got a process of calling out to the world tiles first and then the ants. Can't remember exactly. We can go in there. We can check that out in a little bit. And after some of its updates, then I say, hey world, you can go ahead and draw yourself. Yeah, and then same thing with the ant GUI there. I say, hey, can you update? I actually return a copy of that ant GUI back to the method, so then that's how I'm able to chain these methods onto one another. Right? If we did the same thing with the world class here, I don't return a method there, so I don't return a copy of the world class, so I can't just go world there. This won't work because it's going to say, what's it going to say? There we go. So it gives me this here, cannot draw a world on the primitive type void. Yeah, so I'm just returning nothing there. Whereas down here, I actually return something. That's why I can call it. I can chain those method calls as it were. Yeah, okay. The rest of these guys are basically processing syntax for helping you out with some basic inputs from the user. So scroll the most wheel here. So this is why you guys never chain together if statements, because if you're ever reading your code again in the future, it makes it a little bit tricky to read. Basically, the mouse event has a scroll event, obviously, including the mouse wheel. When it's positive, it's going in the upwards direction, like you're scrolling in, and when it's negative, you're going in the downwards direction, or yeah, or scrolling out. Well, that's what I set it up to for this case, anyways. So basically, I'm just saying, the event .get count is just responding to me how many times I've actually scrolled the mouse wheel up and scrolled the mouse wheel down, so it'll give me a small decimal number there. Let's just pull up the go. So the mouse wheel returns positive values when the mouse wheel is rotated down, and negative values for the other direction or away from the user. All right, so that's that. Basically, I'm now then using those values to calculate, are we scrolling in, are we scrolling out, how much, the delta, right? How much is the change? And then, yeah, this is basically how I'm doing that. And I enabled a max scale and a min scale, right? So once I scroll into something, I can't scroll in anymore. That's because I've said if the scale by is equal to 1, don't scale in anymore. And if it's again similarly equal to 9, you can't scale out, zoom out anymore. I think I got that backwards, but yeah. Yeah, and then this is just a bunch of functionality for if where are you zooming in from, where are you scrolling in from. So basically, I always want to be the zoom not to be centered around the top left-hand corner of the ant game. I just said, all right, make sure that basically we're recentering in on where the mouse is and at each scale level, because I used to have the problem of when I would zoom in, everything would scale up, and that was great. But basically, I would just be zooming in to the corner, and I didn't want to be doing that, obviously. So I had to work in some translation issues there, and so that's what all this is about. I'm just saying, hey, the world map.x, right? You're gonna have to move basically minus equals to where the mouse x is. So equal to where you are, and then minus yourself. Or yourself minus the mouse x, and then equal to your y minus the mouse y. Mouse dragged, again, this is just how we're enabling the drag factor over top of the map, if we contain the mouse, mouse X, mouse Y. So again, so if I'm dragging over here, right on, which you can't see, I'm dragging over here, right, I click, and I drag, the world map doesn't move because the world map doesn't contain the X key, even if it's underneath. Yeah, even if it's underneath. Key pressed, R. Oh, I didn't even know I had these functionalities. Okay, right, because I'd forgotten, because I built this back in the summertime, so it's awesome. So if we press R, we can reset the zoom scale. Yeah, and so scale by equal to 1. So that's why I set up there earlier. I think I had that backwards. World map.x equals 0, world map.y equals to 0. Yeah, so just completely reset the zoom and F. So let's go ahead there and try that. So I'm going to zoom in. So this is probably up to a scale of 9, and then hit R, boom, and scale by setback to 1 again. If we zoom in again, and we click on one of these fatty ants, can I click on you, click on you, there we go. We can see the neural network pop up here in the lower left-hand corner. And if we click F, and take that off there, oh, that's a bit of a bug, all right. I think because maybe I had clicked on it and then I had zoomed in, it didn't know where to go exactly. All right, click on you. Follow you. Really interesting. Oh, you know what? No, I know why it's not centering, because I have the display pulled over for viewing purposes on the screen capture. Yeah, that's why it was always off by like a little bit. So yeah, it does center it. So I thought I had that working. Anyways, yeah, you can follow your answer around. That's kind of cool. Okay, I'm going to R to reset the zoom. No, reset the zoom. Click off you so we don't follow you around anymore, and we're going to go back to processing. Okay, mouse clicked. Do we click over the map or the GUI? Yeah, and again, this is just for some debugging purposes. I think I've had in here. I've put in notes for myself, and I've also put in notes for debugging that I just tend to always end with like 100 print line statements. That's why I have this variable called debug, which that should be wrapped in. But I don't know. And I guess could have debug different levels, right? Where I could say, you know, yeah, debug on true, and what's our debug level? What messages do I want to see, like below a 0 to below level 5? You know, show me all those debug messages. Above level 5, show me those messages, or show me all of the messages. But I mean, I haven't implemented that in this. Just simple print line statements. All right. So if our world.world map contains mouse at the x and the y, mouse x, mouse y, if mouse is equal to left, the world map is clicked at, so left click. So I have this method on our world map called left clicked, and then I'm basically just sending off this event to there saying, hey world, just so you know you were clicked at this event, and then I have that handle it. The notifications for all of the events, for all of the user input, whether it's keys, whether it's scrolling, whether it's clicking, is all done in just this first class, just because it makes it easier for me to find and redo again after, or find and modify if I need to. Whereas if you have like this void mouse clicked event spread throughout your application, you're gonna have to go digging and hunting for different bugs. Whereas right now I can very easily trace where the bugs are coming in from, and where the clicks are coming in from, and where I'm setting off these events to. Yeah, else if mouse button equals right. Yeah, so I think I was going to set up something where maybe I could drop some food in a certain area, or I don't know exactly what functionality I was thinking of doing here. Or maybe if it exists, we can see what it is. So let's go over to our world class. I'm just going to search. No, okay. Maybe it's early morning. I don't know. I thought for whatever reason this left click was thrown onto our world class. No, it's thrown onto the property. You guys probably picked up on this right away, which is our world map was left clicked. So we actually need to go into, well, we can find out if we want to do this the proper way. We can find out that our world map over here, this property is in fact one of our map classes, right? Or a map class, and that will be built in our map class. And now this guy should have the potential left clicked, there we go, the left clicked method. Okay. And do I have right clicked? No. Okay. So I haven't implemented that. So I didn't know what I was thinking when I wanted to implement the right clicked. All right. So human left clicked at a point, find the first ant under that place. No, I'm going to remove that because this was before I had this whole sidebar. Yes, when I left click on it, basically because the click will go right through, right to the back, we have to click on the first one or the top one, and this is basically the code to go ahead and do that. So first I convert the XY, because when I'm at zoom 1, nothing changes, right? When I click in the middle, it'll be 50% left, 50% right. And when I zoom in a whole bunch, and I click right in the middle, I'm no longer at 50% left and 50% right. The screen. Okay, let's see here. How do I explain this? All right, so this is basically what I was trying to explain. This is the short function to do it here. Yeah, we're going to convert from the mouse position and graphical coordinates, not our XY coordinates in the game, right? So basically, currently my mouse is maybe 50% of the graphical way across the screen and 50% right. So maybe that's 500 pixels or something. But in actuality, because I'm zoomed in so far, I need to, in fact, and the scale, remember our 20 wide tile, 20 pixel wide tile has now increased to maybe 40 pixels wide. Well, then I need to convert from my XY in the graphical sense into the actual game sense of where my XY location is. And this is the function to do that. So convert world coordinates to tile coordinates. And again, just short function. I won't step through it too much, but this is how you do it. Now you guys have the code online on GitHub, and this is the code here. Now you know how to convert from graphical coordinates to actual game coordinates while you're doing your 2D animation there, or 2D game. So that took us down a bit of a rabbit hole, going from our mouse clicked, our left button. When our left clicked, we go, so just to recap, when we go from our mouse clicked event here in our primary ant game, we go into the world, we say, hey world, you've got this method called world map. We pass on our left click functionality to that, and world map deals with that, and it's basically looking for the topmost ant that was clicked, and it has to go through a little function of converting our XY location of the click from a graphical sense to the world sense. Now let's check for any other GUI buttons that contain the click. All right, so ant GUI. Yeah, because if we're not in the world map that contains mouse X, mouse Y, we're probably going to be inside of the ant GUI. Okay, so we've talked about the setup here. Now let's go talk about the ant class and the variables and the different methods that we find inside the ant class. I won't go down too much rabbit holes in this one. And by rabbit hole, I just mean if we find a method that goes into another class that goes into another class, we're not going to work our way down there too much. We'll just say it works for now at this point, and then in the future we can do some video on actually getting into how those deeper functions work as we work our way through the classes. No, it's not used. Okay, it's used once. Interesting. All right. Energy, yeah, the raw energy an ant has. So this is also going to be proportional to its size. So the more energy you have, the larger you are. The body size, this can be the actual physical size that we're going to be just drawing to the screen. I think it's like a quarter of their energy or something like that. It's got some logarithmic scale, I think, to it. What's your mouth hue? Yeah, so that's pretty self-explanatory. That's for matching up how much they get hurt from eating the bad, or if they've got a green mouth, they're eating green grass, they're going to be fine. If they're eating blue grass, they're actually going to get hurt and lose some energy, or not get any energy from that at all, depending on how you have your global variable set up. Are they alive? Might be a funny thing to track, but yeah, track it, and then I think at the end of every 100 or so, if this is false, we stop updating them, and at the end of every, I think, 10 ticks of the game, we just comb through all of these and just remove these guys from the game. Breeding size, yeah, so map energy size to breeding energy. So this is again just pulling in one of those global variables that you guys had said earlier into this ant. Death size, very similar too, right? So we're going to be checking their body size against their breeding size and their death size to determine you know, what are we going to apply to this guy. Modifier 0 and 0.1. You might have noticed this little animation on the ants where their mouths kind of pop in and go out, or their noses, or whatever you want to call them, pop in and go out. That's basically a result of this modifier function, and I believe the stands for move. My color. What's my color? Basically, I think we're going to start off with a random color. But you'll see later our different constructor methods allow for different colors to be passed into my color. Generation, yeah, what generation are we? Just track that. I think it's the higher of the parents. Spawn, just tracking just for stats. Feeler 1, Feeler 2, so these are again new feeler classes, so those are basically the two arms that you'll see coming off of each ant. And then these guys have their own methods that we can call on them too. Input. So you might have seen earlier on in the ant game here this input component here. So I guess the idea was originally to have an ant that you could move around with the keys. I haven't implemented that yet. I don't think I will. I'll leave this project for you guys. But yeah, so that's the input. Byte size, I think it's currently set to 3. I don't know if they can change that. Oh no, their mouth size they can't change. Their byte size they can. So when they realize they're over some harmful tiles, they can just close their mouths. For some stats, as well as leading to some birthing conditions. Because if they're less than, I think it was 8, they can't actually breed. Physics circles. So I've created these physics circles. They can't just run in. So they can't just keep going on top of one another. Birth ant nearby. Oh yeah. So yeah, is someone nearby that you can breed with? Of another appropriate size. Okay, so we've got a few different. You'll see 3 different constructors, I believe here. 1, 2, 3, 4. Constructor number 1 initializes the variables or the setting of the object that the class generates. Okay, so basically pass in generation, input, location. Basically, I've gone ahead and I've created 4 different ant constructors depending on which method was calling it. So basically, all of this here in yellow is if you have a parent that just birthed you, you're going to say that your starting energy will be equal to the starting energy that we've determined in the globals settings. Convert energy to body size. So this start energy, that's called with everything. Body, I'm going to give it a new physics circle. If our parent is an instance of brain input, then the input of our parent, we're going to clone it, and then we're going to mutate it. So this is kind of typical of any sort of genetic algorithm where you copy the matrix of weights from the original to the youth, and then you mutate it in some fashion. And then hopefully they do better than their parents. And if they don't, then they die off. But yeah, that's essentially how the brain is working in these ant classes. And if we are on a smart ant input, I'm going to say the learning rate. Oh yeah, so I'm passing in the learning rate to the brain input. Else, if we're not on smart, then I'm going to give them random input. So smart ant. So again, this is a toggle that you guys can turn on, turn off in your global settings. Else if the parent input of random, input is equal to a new random input. Okay, so that kind of makes sense. Just so that if we didn't have a new random input, I'm not sure exactly, but they might just start moving in the same direction. Because they both be controlled by the same input. Yeah, maybe. I haven't tested that theory. All right, yeah, we add up our generation. We get another generation. Mouth hue is equal to our parent's hue plus minus a little randomness. And then this is just some functionality for, I've said that hues can only go up to 0 to 255. So if we're over 255, then basically keep wrapping around the circle. So if we're at 256, so 1 over, then your mouth hue will actually be 1. Birth force, so just kind of funny. When they're birthed, I wanted a bit of projection, so the ant is just kind of spit out from the other ant. And that's just what that does, so I just add that to their body. So that body apply force, and their byte size is set automatically to the max byte size. I think that's probably the most complicated one of them. If you know that one, then the rest of these should be pretty easy to go through. Sometimes when you're first initializing the board, you don't have any ants to be breeding from, so you have to be creating new inputs for all of these ants. And that's how we get to this. I think that's this one, this constructor method. Now, for instance, some of these methods in here, like set birthday, it just sets their birthday. What's the year? What's the day? What's the total day's birth? So basically, I not only do I want you know, hey, we're in year 3, day 30, right? I want to say, okay, year 3, day 30 would be 365 times 3 plus 30 gives me that number. So 1,000, yeah, let's say 1,020 and plus 30. So 1,050, you know. The math is probably wrong on that, but that's essentially, yeah, what total birthdays is. If we need to get the age of this ant, we're going to return the age, switch to random input. Yeah, so this was another function that I wanted the brain to be controlling. If they needed to lose some energy in case they didn't want to be breeding, they could vomit, essentially. They could become bulimic ants. I don't know. Boolean is of breeding size. So again, this is just checking in. Maybe another ant wants to call it on this one, say, hey, you're in proximity of me. Are you of the breeding size? Then it can return, are you or aren't you? Inbreeding distance, Boolean, birth ant's parents. Yeah, so basically, are there any birth ants nearby? Birth ant present. So I even pass in, is a birth ant present? So, okay. Ooh, excuse me. And I do have a key pressed in here. Interesting. Huh. I don't think that this does too much. I really don't. So if this does, I'm going to shrink up the screen here just a little bit. Pull this guy on down. I'm going to click on one of these guys. I'm going to click on, because trust me, I have an ant here off the screen. And if I press a key, no. Okay, so you're actually not doing anything, which is really interesting. Key pressed. Ant class key pressed. Yes, this just telling me where it was. Interesting. I think because this event is being swallowed up, quote unquote, by already over here. Key pressed. I don't know if I can have a second key pressed method. Really interesting. If we wipe that out, right? Save that, stop the game, run the game, and I pull up this guy so you guys can see that. Click on an ant and press a key. No, it doesn't do anything. Okay, really interesting. All right. Not too sure on that one, but that's okay. It's a good experiment. It's fun. Let's keep going. Update the ant. So yeah, so again, the ant's got 2 feelers there. I mean, if I was smarter about this, I could have put their feelers into an array that could, you know, when they breed, they could have 3, 4, 5 feelers, you know, up to a certain amount, based on their parents. Because maybe the ants with more sensors would live longer or something. But I didn't do that. I just hard-coded in 2 different feelers. And then basically have to go through and update the feelers. So again, similar to when we call our world class, you know, we say, hey world, you know, update world, and then draw the world. So here we're going to be updating the feel 1, feel 2, and then if I believe I call it draw on them as well. Yes, I do. So when I draw the ant, so the update, the feeler is happening within the update method of the ant, and then I draw the feelers after. Okay, sounds good. Yeah, so first we update and then we draw. And these are probably being called from the map class. When I say, you know, in the ant game here, update world, it's going to go into the world class, and the world class will then be calling the map class, and then the map class will be calling an array of currently alive ants and updating them, and then that's how these guys get called. And then yeah, and every ant calls each feeler and updates each one of those, and then the map class will call draw ant. And then if is alive, get input from the player or the random or the neural net. Yep, so I'm going to update the body size. Yeah, needs energy to move. Else die. What was the if condition? If, yeah, so if you're not alive, if is alive returns false, which is another method on this ant. Yeah, and then return the ant. Return a copy of itself, right? Now draw ant, draw feeler. Then I'm going to push the matrix so I can translate, because I think these guys, I think I kind of screwed up where these guys were being drawn. Oh, no, that's a lie. So basically, I'm pretty sure that we're translating the matrix before we get to drawing this ant. If you guys aren't sure what pushing the matrix is and popping the matrix is, essentially, hey guys, Future Brendan here, how's it going? I just realized that I went off on a bit of a tangent on how pushing and popping matrices work, and I try and do a bit of a quick tutorial, and I don't do the best job in the world. So in the interest of time and keeping this video on course, please go check out the annotation here if you're not sure of what pushing and popping matrix is. Other than that, we're going to get back to how the ant class works in 3, 2, and that's what this translate is. So yeah, animate. So again, we kind of talked about this earlier with the mouth popping in, popping out. It just helps the, draw the body. Yeah, push the matrix. So this was called from draw ant body. I just kind of removed it so it was a smaller method up there. And again, this is just more about pushing the matrix, popping the matrix, and all that, right? Return, is this alive? This dot alive. Okay. Pretty obvious. Map energy size to size. Yeah, so this is basically, so if the ant's at 100 energy, right, I'll pass in 100, and I'm mapping 100. So what's our death energy? I think it's like 30 or something, or 10. What's our starting energy times 8? So 800, I'm pretty sure, because the starting energy might be 100, and then there's 800. Yeah. So where does, if we pass in a value of 100, where does 100 fit between 10 and 800? And then in addition to this, I have to take into account the map scale as well. Excuse me. Convert energy to body size, get position. You know what? I'll be right back. I'm going to go throw in some tea. Get position. This dot body dot position, right? So essentially the body is one of my physics classes, and the position will be the XY position of that body. I think this is actually, I think it's like yeah, so it's a vector. Okay, so there we go. Great. So anyways, in get position, right, we return the vector of this dot body dot position. So a vector would be a combination of two different variables. So it could be like an x, could be a y, so x, y, and a z. Is ant on map? Yeah. Are you on the map? So you do that. Get size. Returns useful. So as opposed to accessing, if I wanted to in the future here, as opposed to accessing this directly as a property, maybe I want to go through some modification while I'm always using the method get size. So I can go in here and I can modify how that information is returned back to whatever, right? Get sensor info. Again, pass in a feeler because someone might need it. Probably the brain class actually needs it. And they can call back to this ant class here and can get our sensor information from that feeler. Get hue underneath. So maybe the mouth doesn't want to open, maybe the mouth wants to bite, maybe it doesn't. We can test off, and the ant can see it's got 3 points of sight, quote unquote, in the world. It can see where its two feelers are, and you can see right underneath its body. It can also tell what the difference is between the mouth hue and the hue of whatever we pass into it, which will typically be what's underneath the body. Right? That's just a function to calculate that. I don't say the ant can't actually just set its bite size to, let's say, 0 to 3. Right? It can't just do that. It has to actually increase it over ticks of the game. Right? So it has to kind of sense off where it's going to be going, plan off its next route. Hey, there's nothing around me, that's good. I'm going to probably start closing my mouth. Again, return the bite size. If the ant needs to know the world temperature, eat. Yeah, open your mouth and eat what's underneath you. Yeah, and then the energy returned. Eat tile, so again, so I break off some of these functions into their other functions. Eat tile underneath. So this will be then telling us, how much energy actually do you get back from the land, and in fact, is it negative? If we don't have any tiles underneath us, return -1. If it's water, return nothing. If it's type land, and the saturation is, less than the minimum land energy, so I think that's 30, then return nothing because we didn't get anything to do that. And then since we've already returned, we can just keep working our way through this function here. Return energy was going to be equal to our tile.saturation. If our energy is less than our min land energy plus 1, return 0. Maybe not, I don't know. Let me know. And C energy is equal to 0, so what's our C energy? I don't know. Always take bite size from the land, but only return the energy that's digestible within the scope. Okay, so let's say I have a mouth size of 3 and the land has 40 noms, right, on it. It doesn't matter if it's blue, green, or whatever, I'm still going to be able to take away 3 of my bite size away from the energy, away from the saturation, right, of the land. So it's going to go down to 37. But then down here, we actually calculate, well, how much energy do you actually get from that? And is it within the color scope that I can digest? Everything else is just going to return 0. Again, growing feeler. I don't know if it's actually implemented or not in the brain, but if you want to grow your feeler, shrink your feeler, you can do that here. And then rotate. Yeah. Give birth. Yeah. So if you can divide by more than the min weight, yeah, go for it. Get age. If you are Yeah, so if you're less than the breeding size, return, right? These are just some safety checks, quote unquote, right? Even if an ant for some reason wants to try and give birth, we prevent it here. If they don't meet the requirements. So energy is less than breeding size, return. If the age is less than the minimum breeding age, return, which I think that's 8, and I think that's 30, or that's, sorry, 130, maybe, something like that. Set up as our default globals. You guys can change these, obviously, in the globals class there. All right, ants also breeding. So world map gets spawning ants in this proximity to this. So basically we're passing in this ant to the world map. And we're saying, hey, are there any other ants in this location? Yeah. I'm going to, we're not going to talk about this right now. So we're going to create a new birth pod. And BP, we're going to add this. So my birth pod was my solution to how do we have multiple ants breeding at the same time. And then the birth pod handles the logic of, do I have 1 ant? Do I have 2 ants? Do I have 15 ants? All breeding at the same time. And then, so yeah, we can just go ahead and add all of those ants to this, and then birth pod, we can then call birth on it now that it knows all the ants that are going to be involved in the process. Yeah, it can go ahead and call birth on that, and then the birth pod will call back to each one of these ants and say, hey, you have to reduce your energy by so much, and then the birth pod will in fact spit out the new ant at whatever location it determines is the best location. And die. So this dot alive is equal to false. This dot accumulative death day. So whenever you see a cumulative here, accumulative birthday, accumulative death day, basically that just means if we were born at 3 years and 30 days into it, right? So whatever it was, 1,020 or something, or 1,200. Let's call it 1,200, right? We'll make it easy. If you're born at 3 years into it, 1,200. We'll say sure, 400 days in a year. And you die at year 5, and there's 400 days in a year. Well, then you actually died at accumulative death day of 2,000. 400 times 5 years is 2,000. And then so we'll see how many days you were actually alive for. And then the world map, remove this ant from the game, so we don't see it anymore. Okay, guys, so that was it for our ant game here. We kind of covered over these basic methods of the drawing, the mouse dragged, key pressed, do we zoom in, mouse clicked, all of that. We dove a little bit into our world class over here, and we dove just a little bit into our map class, but mostly we covered up the ant class, the different properties, how you birth it, what's the constructor, all that stuff. And then hopefully next time we'll be talking more about what these BR display classes. I'm just working my way from left to right, but maybe that's not the best way to do it. I'll think of something for next time here. But yeah, basically that's what we covered. I hope you guys enjoyed it. As always, let me know down in the comments. Like if you liked, dislike if you disliked, and as always, just leave me a comment with some feedback. Talk to you guys later. Bye.